what we do at Starof. We are a vibrant community of Java developers where you could find interesting career opportunities, engaging resources to learn new things, and the opportunity to network with experts and seek their help. With our webinars, especially we seek to help developers learn new frameworks and tools that make them productive at work. And for that, we bring lighthouse speakers from the world of tech. Leading today's webinar is Alan Williamson, a truly special speaker and expert in the world of Java, and he joins us from the US. Very quick introduction about Alan, because he's done a lot of things. Just want to give a very quick intro to his overall profile. He was the first UK Java champion, and then he was recognized among the top 100 Java champions in the world by Oracle. Because of his contributions to the world of Java. Alan has published a number of books in the Java space, covering enterprise Java, servlets, Java mail, and database access. And he has also served as the editor-in-chief for the Java Developers Journal, one of the largest magazines in the space with 200,000 subscribers. He has recently signed a publishing contract with Manning Publications for his upcoming book, Think Like a CTO, that is aimed at new and upcoming CTOs. Alan has been a sought-after tech leader and a CTO at multiple tech companies. He has experience in building, mentoring, and scaling out teams to execute current and future requirements of the business. And personally, Alan believes software development should be a lot easier and far more reliable, which is becoming very important as several of these systems have become the mainstay of our lives. We need to ensure that these are very reliable. So he takes he takes no prisoners and is quick to call out fads and trends, that merely rehash old techniques is something new and shiny. So a very interesting speaker. The session will take about 50 minutes, and we will have like 10 minutes set aside at the end for Q&A. So do share your questions in the chat, and we will have Alan answer them for you. So with that, I turn it over to Alan. Alan, all yours.
Thank you very much for that wonderful introduction. And thank you for inviting me to talk with you all this evening. I hope I don't take too much of your time this evening. And if I do, then it's valuable for you. So yes, I'm going to have a quick look at effectively the difference between a coder and a developer and how you can manage your career in such a way to be a valuable contributor to our overall ecosystem. So assuming everybody can see my screen okay, so as the introduction wonderfully put, I am indeed Alan Williamson. I am based here in the US, originally coming from the UK, and I'm currently working in private equity. And one of my roles there is to help train and mentor up-and-coming leaders, develop development teams, because some of the companies that we invest in are not traditional software houses. They'll have grown a team from maybe 1 to 2 to 3 developers that have maybe now got maybe 50 to 100 developers as part of them. But nobody there has probably led a team of that size before. So sometimes it's blind leading the blind. Sometimes it's simply not knowing some of the techniques that they should be doing. And part of my role is to sort of help them through some of the smaller things that they can do to truly make a big impact. And again, think of it like changing a shipping tanker. You don't turn it quickly. You sort of nudge it a little bit at a time in order for the team to start working together as a whole. So you may have heard of this quote before. It's one I use often, is that coding is the easy bit. It's the development that is hard. So we're going to look at what that means today as we go through this. And effectively, we're going to split up what is a developer and what is a coder. We sometimes conflate the two and we think they're the same skill set. They're not. They're completely two separate skill sets. And working with teams, when I meet somebody and they say, I'm a coder, and they proudly say that, I say, you're not. That's the easy part. You're a developer. And I'm going to show you why you're a developer and not a coder. Don't underestimate yourself. Don't undersell yourself. And once we've defined what a developer versus a coder is, we're going to look a little bit about further down the line. Where can your career go? What are the skills that you need to become more successful or create a richer contribution to our ecosystem. So as noted at the introduction there, coding is more of an art than it is a science. Now, why do we say that? Well, we say that simply because there's an awful lot of flair and a lot of us that we can put into our creations. It's one of the most beautiful things that we can do to do this. Because if I was to ask for a hello world example from each and every one of you, I'd get individual differences coming back. They wouldn't, not one single person would probably give me the exact same code coming back the way. That's what makes this industry so wonderful. It's also one of our biggest problems, is this huge variety in interpretation of what we're trying to code. So let's look at what we think is the fundamental difference between a developer and a coder. So a developer, they're really the one that tries to decide what we're trying to solve. And they break down the problem into a series of little mini problems that we try to represent in pseudocode. Okay, anybody that's gone through a traditional computer science degree was probably taught this at a longer level. I remember back in my days, I studied robotics and embedded software. And one of our first things we had to do was, how do we make a cup of tea? What are the steps to make a cup of tea? As young, fresh, pimpled developers that we were back when we were 18 and 19, we all said, oh, maybe 8 steps, maybe 10 steps, maybe 13 steps. Professor showed us it was over 300 steps to make a cup of tea. This human body that we all inhabit is such a wonderful machine. It's doing so many things that we don't realize it's doing. But that's the art of a developer. It's trying to figure out what each of these bits is doing to figure out what it is we actually need to execute. And that's what a coder does. A coder takes each of those little problems and physically creates the code that we can execute it. Coders, we get excited. We get excited in our art. And why shouldn't we? It's what makes us who we are. We love to code. We love to create something. It's in our DNA. But sometimes we lose sight of what we're trying to do. We're too quick to have our code show off. We're too quick to have the code be everything that defines us, not what the code is doing, right? And then think back about what has impressed you when you look at your own code or you look at somebody else's code and they're describing it to you. I mean, chances are somebody at some point has shown you a clever little hack or a clever little loop that you think, wow, you've done that in 2 lines. It took me 15 lines to do the exact same thing. And you think, wow, maybe I'm not a great developer. This guy's done it in 2 and it's taken me 15. He's like 7 times better than I am. They focus too much on the code, not the solution. We're trying to find those little hacks, those little quick shortcuts to make things easier. Not the right attitude. So when we think about how we develop, when we think about what we do and the tools of our trade, you know, if we were a painter, we would have a brush, we'd have an easel to fill works. What would you say is that this precise moment is the most efficient go-to tool for your coding and development at this precise moment? Is it an IDE? Is it an editor? Is it a tool? Let me give you a little secret as to what it is. It's a good old-fashioned pen and paper. I'll give you a whiteboard. Whiteboard is my preferred development environment of choice. Why? Because the whiteboard is the #1 platform where everything works. Nothing has ever crashed on the whiteboard. Any solution, however complex, however small, works on the whiteboard. No bugs are found in the whiteboard. It's only when we try to convert it into code when things go wrong. So that's why I love the whiteboard. On the whiteboard, I'm a genius. Everything works. But in all fairness, the whiteboard or the pen and paper allows you to make changes very quickly. It allows you to think quickly. It allows you to make things and move things around and figure out, is this going to work? Is that going to work? Is this going to make an impact here? Is this going to make an impact there? It allows us to actually develop the solution, not code the solution. By the time we get to the coding part, we've probably identified we may need to say, take an array and convert it to a different format, or we may want to sort a hash map. When we get to that level, I mean, it's fairly straightforward at that point. It's easy. There's nothing to solve. We're just translating that. But development, whoa, that's the exciting part. So let's look at some of the things that sets us apart from being a coder and a developer. So we've probably seen some of these before. So the first one is readability beats shortcuts. Okay, so what do we mean by that? Well, we're back to our example of where, the 15 lines of code that you developed in the loop that you thought was really bad. You thought, oh God, because this guy did it in 2 loops. Well, chances are your 15 lines is probably a bit more readable than their 2 lines. Okay, there's probably things going in there that you're thinking, wow, I didn't know you could do that. One language that suffers a lot from those sort of hacks is JavaScript. I mean, anybody that's ever done any JavaScript, we all go running back to Java quickly because give us our type language, please. I don't like this looseness of JavaScript and all the hacks that you can do in JavaScript. And these creates problems for the JavaScript IDE people or the language people, because people start relying on these hacks as if they're language features. And you sort of look at it and thinking, no, they're not. That was just a sheer fluke of what happened. I was one of the core architects of the CFML to Java runtime engine that we used in MySpace and various other stuff. And we basically wrote a CFML engine that in Java that was effectively a development of web scripting language. Macromedia and Adobe was our reference implementation. And what we discovered was that there was lots of little things that the language would do that was never designed by either party. But legions of web developers had relied on the way a certain tag combination worked in order for them to produce their end result. So we actually had to build in these mistakes into our language in order to mimic the golden language. So again, readability always beats shortcuts. And secondly to that, reliability always beats performance, right? We want a heart pacemaker to run 100% of the time, not 90% of the time. But that's how we treat some of our code. I'll work for most of it, don't worry. I mean, you'll never hit it. No, we want 100%. You should demand 100%. There's no reason you cannot have 100%. It's just we get lazy. And as part of that, always assume bad data. Algorithms generally don't fail because they're inherently wrong. Not at our level, because by the time we're using an algorithm, they've already been thought out. An algorithm usually falls because of bad data, the unintended noise in a system. We have a string of arrays, an array of strings, but nobody ever thought that one of those strings could be a null. Poof, death. Or the classic one, oh, I thought the strings were going to be clean by the time it came to me. Again, assume the worst intentions. The amount of time and overhead it's going to take for you to clean up some variables or to check some variables is minimal in the grander scheme of things. Okay, so always assume bad data. No matter where your function is, where your method is, where your class is, don't rely on that. Now, the good news is in Java, we're a typed language. So we can rely on certain things to be there. Look for nulls and other various stuff, particularly in a polymorphic world. We've got to make sure that we've actually got a concrete class versus a subclass of that one. But the premise is still the same. We want to ensure the validity of our data coming through. to make sure that when we actually execute that method, it's going to do what we need it to do. Failure is a when, not an if. And anybody that's coding today, chances are you're coding for a cloud environment or a distributed environment, a microservices environment, a web environment. That means you're being called all over the place. That means you're relying on third-party services. In the old days, it was probably just a database and file system, okay? And we'd have lots of little code to make sure that we didn't run out of disk space. We didn't do all that sort of stuff. But how good is your code when, say, that API call that you're making doesn't return? It doesn't fail, it just doesn't return. I mean, so your code is hung now on that call. Or the database that throws an exception halfway through a select or an insert statement. The amount of code that I've seen that you run your finger down and say, right, okay, that call to AWS to put the thing onto the queue, what happens if it never returns? And I can assure you that happens every so often. Or that select statement you've just run through the Postgres driver to run the select statement, your exception handling, that's not going to do what you think it does. So again, look at what happens. In an ideal world, we don't want to have to worry about things failing, and we don't. And its close cousin is security. You know, we always joke, God, I wish everybody would just get along. Wish everybody would just trust everybody, because I wouldn't have to build in all these extra layers for security and all that sort of stuff. But the world isn't like that. Stuff does break, and we have bad actors. Okay. And how's our code, how's our solutions being developed in order to account for the fact that things are going to break? And it's very important, because that is what truly defines how strong a piece of code is its error handling on that respect. Another one that we see a lot of, I mean, this is probably in the top 3 of guilty sins that is done by most developers. Break things up. Don't try and solve everything in one class or one file. The amount of times we've seen loops that are like 10, 12 embeddedness, you know, you sort of have, when you start have to horizontally scroll to read the page, you know you've gone wrong, okay? Small hint. Break things up. Break things up into smaller, discrete, solvable units. Instead of sorting that array in the middle of a for loop, take it out and put it somewhere else. Instead of making that API call straight in there, break it out, put it somewhere else. So it can be reused elsewhere, but you can also instrument it. You can also put code around it to ensure its validity, to ensure its accuracy. So deep inside of your loop, it's then much more manageable. I always like to code things in such a way that I'm effectively outsourcing the problem, which is, and it's usually me that's doing it, but fundamentally I'm going through code and I'm saying, okay, that's a problem to solve. That's a problem to solve. That's a problem to solve. If I'm needing to make a call out to an API to put a piece of data onto a queue, then I say, okay, here's the data. I'm going to toss that to a method somewhere to go out and do that. Why? Because I may want to log it. I may want to log how long it took me to put the message onto the queue. I may want to try and do it maybe 1 or 2 times if it failed. And then I'm going to probably do something completely different if it does fail. Now, there are so many different actions I'm going to do there for a simple API call. I'm not going to put that inside of a for loop at the time, because I'm going to use that elsewhere all over the place. But it's a guilty sin that most developers do, because they assume I'm only ever going to do this once. I'll just put it here. It's going to be more efficient if I put it here. No, it's not. Think about your overall code and where you want to put stuff. Excuse me. And my last one here, which always amazes me. Format your code to be readable or readable. When you look at blocks of code, how many blank lines is it? Is the curly brackets in the right place? Does it look like something I want to read? Or is my human brain trying to parse the code to figure out what the semicolon is, to figure out where you've embedded stuff? It's a mess. It's horrible. I've only got 15 minutes to do code review, and you're making 10 minutes of that decoding your actual code. Stop it. We wouldn't read a book without any full stops or carriage returns or chapters. We wouldn't want to read something, a big clump of text. But that's how often we see code produced, particularly by juniors. But some of the seniors are guilty of this too. Format code. It's okay to have good looking code. Nobody's going to think any less of you. Quite the opposite. Now, some of these issues here can be solved through tools. The correct IDE, things like SonarQube, things like coding standards. Coding standards are there for a reason, not to hold you back, but to excel you forward, to make your code much more accessible by others. So again, think about what you're producing, not what you're trying to write. So we look at our code as a whole. And again, we're thinking about what is it that makes us a great developer? What is code maturity? Code maturity is coding for the unexpected, okay? Those edge cases, the whens, not the ifs of when failure happens, okay? If my code can tolerate the database not being there, and when it comes back up, I'll start working again, then brilliant. That's what we want. Remember, for some of the more seniors around us, back when stuff used to break, we'd have a cheat sheet of the order of things that had to be brought up in order for things to work. We've got to make sure the database is up. Then we bring up the Java application server, because the Java application server needs to have the database before it runs. That doesn't work today. It doesn't work in today's clouding environment. So we have to build for tolerance. We have to build for a changing environment. What do I mean by that? Well, cloud microservices is a perfect example. I've got my code. I'm hitting a database. I'm hitting a database. I'm hitting a database. Oh, shit. Database has died. It's gone. In a cloud environment, that database is going to be brought up somewhere else. It's probably going to have a different IP address. Will your code now be tolerant enough to start talking to the new database? Or does your code now need to be restarted and reset and configuration updated? So simple little things like that is what makes a huge difference. Back when I was in my sort of junior state, one of the best things that I was ever done, I was forced to be effectively, it used to be called an ops engineer or a systems engineer back in the day. And my role for 3 months was deploying other people's code. Best eye-opening system I could ever have had. Why? Because it showed me how little developers really understood about the environment they were running in. They assumed paths for temporary files. They assumed hard-coded IP addresses or stuff to variables. They assumed an order of startup. Even in a configuration file, the amount of times I would see code that wouldn't even validate the data that's inside of a configuration file and then just blow up and wouldn't start. Where was the line in the code to say, hey, the port for the database is actually a string, not a number. You need to change that. That needs to be fixed. That helped me as the ops engineer know exactly what the problem was. But most developers just say, oh, crash, can't start up. Why? You figure it out. You've probably got something wrong in a configuration file. And we see that a lot, even with open source projects, some of the older stuff. You start something up and it's like, oh, good God, where the hell is this gone wrong? I've done something wrong in a file somewhere. YAML files. Wrong format, boom, dies. Awful format, right? Tell the user of your system what's going wrong. Tell the user why your code is not able to execute. Do not sit on that valuable data. And finally, adaptability and accessibility by others. So what do we mean by that? Well, again, talk about our big, huge code block. Yeah, that's great. It's great, but that little bit there in the middle of that for loop, oh, that's genius. That's beautiful. I love what you've done there, but I can't use it. I want to be able to use that bit in somewhere else. You've got to unlock the way some of your beautiful your creations inside something that's not accessible. And because you've written it in a huge long file, people can't even see that it exists. So, well, I know he calls the database, but hell, I can't seem to find it because the code is like a 10,000 line file. Or I know she can talk to a Lambda and get it started up and move it forward, but I just can't find the code. It's just not there, but I'd love to be able to take that out and use it in mine. So again, let your code breathe, let your code exist in a larger team. That's what it's all about, is making sure that you have got much more contribution to the overall team. So as we're developing, what can we do? Well, we do this at a single line level, but really we're talking about at a method level, okay? But the same thing applies. We've got to look at that code and sort of say, what could go wrong? Where could this code break? What am I assuming is needed here in order for that to work? Okay. And, we talk about nulls. I mean, the null pointer exception is a Java developer's best friend. If you've never had a null pointer exception thrown in your Java code, then you're not a Java developer. Okay. But yet, we find it the hardest one to try and find. Because again, we're assuming clean data. We're assuming, oh, by the time it gets to this method, there's been so many checks done that it's never going to be null. Of course, it's going to be null at some point. So look at your code and ask yourself, where is this going to break? And then put in the if statements, the checks, the asserts to get you around that in order for your code to be far more brittle. And again, just simply don't throw an exception. Throw an exception with meaningful messages in it, okay? So many times, and likewise, don't write a whole essay inside your exception message. Keep it concise. You're making it to allow a system engineer or a site reliability engineer to be able to figure out, why did that code fail? Is it something external that I can figure out and change? You look at your code. You've done your 2-line hack, and you say, well, could somebody else understand this? If you want to make sure that other people can read it, okay? It's really that simple. You're coding for other people. You're not coding for yourself. You're always coding for somebody else. And could you make it easier? Now, easier does not mean faster. Easier does not mean quicker. I'm talking about, could I take this code and expand it out in such a way, maybe create more methods or lay out the code slightly different to make it more readable, to make it easier to understand? Do not code for performance. You will fail. Even the top guys will fail. All of those clever little hacks and clever little articles saying, well, if you use a string builder versus a string, no, forget about it. Today's JITs and today's Java compilers will outperform you every single day. So don't do it. We are not at a level that we're coding that we need that higher resolution. So what are some of the signs that you're probably not going down the right path? Well, code ages. Code goes off and executes, goes and does its thing every day, running away. You don't look at it all the time. Then something goes wrong because you didn't follow the steps before. And now you got to look at it, and you look at it and you're thinking, whew, what the hell was I thinking there? Because you've forgotten the problem that you were trying to solve because you probably haven't put in comments. You're probably on a different project now, so your mind has already shifted from something else completely different. So that third line in that loop statement looks completely out of place now, but at the time, it made a hell of a lot of sense. But for the life of you now, you can't think what it is. And in a flurry of inspiration, you say, I'll just remove that line. It doesn't look like it's doing anything. And then everything else starts breaking, okay? So if you can't even understand your code, then what help is somebody else going to have to do come behind you? I have written code 20, 30 years ago that's still executing to this very day. Code lasts a long time. Now, could I go back to the code that I wrote when I was in my mid-20s? No way whatsoever. And it probably wasn't written terribly well because I've got, 30 years of experience since then. So I would like to think my code today is way better than my code is back then. And I know I was a bad coder by this definition because I was thinking about me. I was thinking about my code, not where this code was going to live. Then we get into these sort of situations when you are in a large team, something breaks or something needs to be changed and nobody wants to touch it because it looks too complex. Back to the first one, but they truly don't want to look at it because they don't understand your style, your way of using Java, which basically is a shorthand for saying your hacks. Those little clever things that you read on Stack Overflow or some blog, you thought, oh, that looks cool. So much code could be reduced because I don't need to produce so much code because I can do this in 2 lines. No, you've lost the battle. And here's one that always catches out the junior developers. You've solved something, you've produced your code, it's doing what it needs to do. The client comes along and says, I think I need to change something. That processing on one web page, I think we'll split it up into a wizard now. We'll put it over four web pages. And use a developer going, that was supposed to be 1 API call. Now they want to do it in 4 API calls. Oh, crap, I've got so much to do. I've got so much to change this. Code will always change. Why? Because the environment to which it runs in always changes. We're always evolving our solutions. We're always evolving the business that we're trying to do. Any piece of software that you look at this precise moment, whether it's Facebook, Twitter, Google, anything, are they running the same code that they were running 10 years ago? Even a year ago? They're running some of it, yes, but the user experience is always changing. We're always evolving. We're always trying to get things better. As we as developers, underneath the covers, we're trying to keep up with this. We're trying to make sure that our code, we're not having to go back and reinvent every single time just because something changes or something does, okay? And the worst thing that you can do as a developer is saying, it can't be done. Well, you just can't do that. I challenge that every single time. You're running in a virtual environment. Anything is possible. We are only limited by our imagination. Just because you've coded it in such a way that it cannot be adapted because somebody has said, it needs to do this. That's not their fault. That's your fault. You haven't developed the solution. So don't be so quick to code. Step back. Think about your code. Think about where you can break it up. Think about where you can do things and sort of make it much more accessible to not only you, but to others. So when you have to make that API call, and you have to ensure that that API call is a bit flaky and sometimes needs to be called 2 or 3 times before it gets through, because whether it's internet connectivity because you're in a mobile app and you just don't have a reliable network, or the third-party service, for whatever reason, is just flaky, then develop that in such a way that you can reuse it. Don't just code it. It's not code and done. You're developing a solution. So those are the differences between basically a coder. And for the last sort of 10 minutes, I'm going to look at your career as a whole. Okay, so hopefully we see a little difference between what a coder and a developer is, and how you as a developer can truly create a knowledge base and a skill set to accelerate both your team and your company so you become valuable. But where is your career going as a whole? I meet so many developers that all they want to do is code. And you say, that's great, I love it, you're wonderful, you're young, and that's what you should do. But what is it you want to do? Where are you going? What are you defining as a success? What makes you go home at night and say, I did a good day's work? What is that threshold? Because let's be frank, this is a passion industry. Most of us are doing this because we love it. The fact that we're getting paid for it, that's a bonus. Because we love it. We absolutely love what we do. We're not digging ditches. We're creating something where we're in this. It's a wonderful world. I love it. Development is the best job in the world. But if you don't know where you're going, how do you know when you've arrived? A typical career path for a developer is what's on the screen. Some companies will have different titles. Some companies will have different paths. Some companies will have different checkpoints in between each of these. But generally speaking, this is our development career. And these are the ones that I've highlighted that we generally get paid for. As a junior developer, of course, the road before a junior developer, because we've probably started tinkering in our back bedroom. We've started probably doing stuff at school way before we were getting paid for it, because that's what we can do. That's what's wonderful. My stepson's training to be a brain surgeon. Now, there's something he has to go to school for. He can't come home and sort of try out on other members of the family. Here, I've learned something new today. I want to try it. No, but we as developers can. There's nothing stopping us. Give us a keyboard, give us a computer, we can change the world. We need nothing else. That's what's exciting. So we start off as a junior developer. And we start learning, we get out of the mindset. And junior developers, I think of them pretty much as coders. All they're there is just producing code. That's all I want to do, produce code. Then you realize that code isn't everything. Code is actually the easy bit. It's developing the solution. So we sort of migrate up into a senior developer. And then we become an architect, where we start thinking about things in a bigger environment about, okay, well, I'm not just developing this solution. I need to think about it in a much more, say, in a microservices environment or in a cloud environment. Much bigger skill sets required because I'm now thinking at a higher level. And I've got to think about some of the enterprise tools to which I can solve some of these problems. Then I might migrate up to, say, a head of group or a head of a product, where I'm now responsible for the overall life cycle of this thing that we're building. Then I may jump up to a VP of engineering typically, and that's somebody that's overseeing a number of different product teams, and they're responsible for the overall execution of a company. Then we've got CTO. They're responsible for the overall technology of a company. The decisions that they make will affect how a company can be profitable, or new opportunities that can be had by the company through the decisions that they make. They're thinking more longer term. They're thinking like 5 to 10 years in front of stuff, okay? And then there's a life after CTO. Perfect example here, I now work in private equity. I didn't even know private equity existed way back before I was a junior developer. Frankly, I didn't even know CTO existed way back. All I wanted to do was give me a keyboard. I just want to code. That's all I want to do. Just let me code. So ask yourself, what is it you want from life? What is it you want from this career? Okay. You want to have skills. Of course you want to have skills, but you want to have skills that are good enough that somebody actually wants to pay you for them. Okay. No point in having the skill if nobody's going to pay you for it. We want wealth. Now, we're not talking about being millionaires or billionaires. We just want enough money for us to live. We want to put food on the table. We want to provide for our family and have a little bit in our back pockets so when life throws us certain events, we can cope with them. We're not looking to be millionaires. But we want a certain level of wealth that will allow us just to enjoy life. And then there's fame. Some may want to invent something or build something that changes how we think about things, however big or small. Somebody had to invent Facebook, for good or for bad. We can talk about the social impact of Facebook at a later date. But that was invented by somebody. Twitter invented something. Machine learning, somebody invented that. Java, James Gosling invented Java. Think about what that one man did and how many millions of lives he affected because he invented a language. So it doesn't matter how small or how big it is you're doing. We've got the power to make big changes in our world. And that's exciting. It's very exciting. But don't let anybody fool you. As we move through this road, go through all those different permutations, it's never easy, no matter who you look at. Whoever you think has got an easy ride, they don't. Who's heard of imposter syndrome? Imposter syndrome is that feeling of you don't belong or that you maybe don't know as much as people think you know. I have a whole chapter dedicated to imposter syndrome in my Think Like a CTO book. It affects us all. Who am I to tell you about your career growth? That's imposter syndrome. Of course, I had that about 10 minutes before I give this talk. If you get nothing from it, then I apologize for wasting your time. But if you get something from it, then great. I've moved the needle. Point is that you're going to make mistakes throughout your career. It's what you do with those mistakes is what's going to define you. And that's what's going to be looked at by employers and future team members. And as you go through your career, the people that you're working with at this precise moment, they're all going to shoot off in different directions. And who knows that junior developer that you're mentoring at the moment, maybe one day he's the CEO of a large organization that taps you at a later date because you showed them empathy, you showed them patience, that they're now going to hire you. Say, I need you to run my technology division because you get it. So never assume every interaction, see it as a career networking opportunity. And as we come into the last of this, we think about where we're going and the skills that's required for each of these different areas. One of the things that I keep telling up and coming leaders in this sort of stuff is your skill set as a coder becomes less and less the further you go down this chain. Because if we look at the yellow box here, you're interacting more with people that are not technology literate, okay? Business people, end users, clients don't really care how you do something. They just need to know that it works, okay? So you now need to develop those soft skills to be able to convert their want into something that'll work. Now remember, maybe 30 odd years ago, there was this bald-headed guy called Jeff, who decided he wanted to sell some books online. He asked somebody, could you build me something to sell some books online for me, please? And he did. And I think we can all agree that the person that built the thing that sold the books online got it very right, because they created a whole ecosystem. From that little acorn grew Amazon.com. From that little acorn grew AWS, a whole cloud infrastructure, the largest cloud company in the world. And it all started because some guy said, I need to sell books online. And this new thing called the internet. Don't know if it's going to take off yet, but I think it will. So that Jeff really inspired a whole generation. And it was everybody in the yellow box that made that happen. They're the ones that envisaged AWS. They're the ones that made it work. So soft skills is what we talk about there, is that ability to interact with the outside world, i.e. non-coders. That's what we call the outside world, okay? And you become salespeople because you have to sell your idea. You have to be a way to communicate your vision, communicate your ideas, because the architect has to sell what they have come up with to the head of the group, saying, right, we're going to use this cloud, and we're going to do this, we're going to do that, we're going to do this. And the head of the product is going to say, explain that to me. Explain to me the reasons, the benefits, the advantages to me. And that's going to take something other than just showing code, because the architect's going to have to sell, right? We're going to buy a whole rack of servers, but why are you not going to the cloud? Well, it doesn't matter what the reason is. They've got to sell their idea. The head of the group's got to sell it to the VP of engineering, and the VP of engineering's got to sell it to the CTO, and the CTO's got to sell it to the board of directors, because somebody has to fund this. So we're all selling, we're all promoting, we're all communicating, we're all trying to get there. But it all starts effectively knowing our trade, and our trade is coding. And that's where our real value is. Our real value isn't coding. Our metric of success is solving problems. That's why people come to us. They don't come to us to write code, they come to us to solve problems. Because at the end of the day, the end client, the one that's writing the check, does not care how it's done. They just want to know that it works. And it works every single time, period. We don't want the heart pacemaker to fail 10% of the time. We want it to work 100% of the time. And it's amazing where our code will find ourselves, whether it's an embedded software, running on a web server, running in a car, particularly Java. We all know Java runs everywhere. So you just never know where your library could find itself. You never know where you could be asked to code. But the one thing is for sure, everybody that's asking you wants it to work 100% of the time. It's a hard goal to achieve because there's so many external factors, but really, that's what we're aiming for. That's it, good people. Thank you very much for your time. And if there's any questions, happy to field them.
Hey, thanks, Alan, for a brilliant session. I've got some questions that got forwarded to me in private, so let me read them out based on what I think is relevant for the group here. So there's one question, and this one gets this one is asked all the time. So the question is, how do I decide whether to specialize or to generalize in my development journey?
That is a beautiful question. And the simple answer to that one is follow your heart. Okay, follow your heart. We are in an industry that reinvents itself pretty much every 5 years. Mm-hmm. Okay, so therefore, you're being asked as a developer to continually learn every single year. Okay, we're not like sheep shearing. I always default to my sort of when I'm bored and I'm just going to go and herd sheep, because we've been herding sheep the same way for thousands of years. It hasn't changed, okay? But in our world, we change all the time, okay? So if you're not interested in it, and if you're not following your heart, you're not going to keep up. You're keeping up because you want to keep up, because it's natural, it's interesting, it excites you, it gets you out of bed in the morning. But if you start to specialize because you think there's money in it, or you think that's where people are going, but you're not excited about it, then don't follow it. Don't go down that path. It's just, it'll bite you in the bum at a later date.
Right. That's good. Yeah. So there's another question. This one's, I think, more personal. So there's somebody who's working for a large company where he is having a hard time getting his senior developers to introduce new tools into the project. So his question is, at a very early age in my career, does it help to work for a large company, or should I just, let go of the advantages that come from being, working at a large company, and then try something more exciting at a startup or things like that?
Yes, I mean, it's a beautiful quandary we find ourselves in. My own son, who's just graduated from Edinburgh with a computer science degree, my advice to him is go to a large company, go to a big public company, go into an environment that's structured. Okay, you're going to be such a small fish in such a big pond. Doesn't matter. Why? Because you're going to see how the big boys do it, and you're going to see the structure and the process that the big boys do it. And here's a little secret that only you'll know when you do it. The big boys don't know what they're doing most of the time either. Okay, they're equally in a disarray at some of the things that they're doing. And big boy doesn't mean quality, but you need to see that for yourself. You also need to go into a bigger organization to see, how can I make things better? I mean, it's no coincidence that a lot of startups are born from engineers that have left Google and Facebook and Twitter and all these big boys because they've seen an opportunity and said, well, I'm going to do this better. In the Java ecosystem, the amount of people that left Sun Microsystems at the start and then went off to do, a Java application server or a Java messaging server, or built a whole ecosystem. Why? Because they had experience in the bigger picture that they could find where they could plug themselves into and create a solution. Now, to answer the first part of the question, as a junior developer, how do you get your seniors or your leadership to introduce new technology into the organization? The simple answer to that one is, you're going to have to show them, right? You're going to have to show them how to do it. There's a great TV series from HBO, From Earth to the Moon, which charts the Apollo mission back in the 60s. Tom Hanks produced it, and it's a wonderful series. Episode 5, the spider episode, is the one that I show every single engineering team that I take over. It's a 50-minute episode, and it shows how Grudem engineers convinced NASA how to do certain things. Okay, and for me, it's a metaphor for software development. So, for example, there's a scene in it where the developers, they're going to say, well, the windows are too small. The astronauts can't see out of the windows. And NASA said, that's all the window size that we can have. So they had to convince NASA that this wasn't quite the way to do it. But what actually turned out was that the engineers figured out, well, let's build a mock-up. And what if we had the astronauts stand up instead of sitting down? Then the window would work. And NASA said, we don't see it. We don't see how that's going to work. But they had to build it. They built a whole mock-up of the lunar module to show them that standing up as an astronaut could actually work. How do we relate this to our world? We as junior developers, we've got the time to sort of say, well, okay, they don't see it, but let me build something to show it. Instead of me sort of pointing at something saying, yeah, we should use this framework, we should use this library. Go and use it. Do it. Fork off that code. Build it. Have your decisions led by data, not by instinct. That's how you win. And if they still don't accept it, then at least you have tried. And then if you're close enough, ask them, okay, teach me. Teach me why this isn't a good thing to do. Teach me why this isn't the way. I've had to say no a lot of times as a CTO to new things coming to me. And most of the reason that I've said no to it is because the new language or library is just a little bit too new for me to bet the farm on. Okay, so for example, there was a time I was lobbied hard to move a lot of our Java engineering over to Node. And I resisted it a long time. And the reason I resisted was because the Node environment was so small. I couldn't hire engineers for Node. There wasn't enough documentation on Node. There wasn't an ecosystem around Node. I wasn't discounting the language. It just wasn't big enough for me to be able to say to my leadership, hey, we're tossing out Java, we're going to go with Node. But I've got like 1 million developers I could pull from here versus the 5,000 at this point. Why are you doing that? So sometimes the reasons for saying no isn't what you think it is. Sometimes there's higher up reasons, but ask, but never give up.
Cool. One last question is, this one's again a little tricky. There's this guy, Abhilash, who says that he's been working as a front-end developer for about 4 years now, and he has seen a lot of his friends who went into back-end graduate into architect roles and on their way to become product managers. As a front-end developer, he doesn't quite see the same opportunities for him. In your experience, has this been the case, and what can he do to kind of get up for broader roles?
Yes. Unfortunately, there are certain disciplines in our world that do reach a natural ceiling. Okay, so those colleagues that have gone to the back end, they have a much wider field to play in because there's more opportunity to do things there. Now, that's not to say in the front end world there isn't. I mean, the front end world, there is still a lot of innovation happening. There's still, I mean, look at all the different variations of UIs and new experiences we see in the web today. We clearly haven't come up with the web standard on that front. So, but it's a fair point to say that there's far more opportunity in other disciplines of the world. Now, again, we can liken this to other fields, like whether it's like data scientists, for example. People will either go into sort of big BI solutions and start developing solutions down that path, or go into more AI, machine learning, or now there's blockchain, etc. We don't know where the ceiling of each of these different paths are. Sometimes they reach a plateau quicker than others, and sometimes they don't. The issue with the UI people is that they are very visual, and a lot of the time, and I always hug my UX people because they're the ones that make the rest of us look good, right? As an enterprise developer and a back-end developer, nobody sees the beauty of our solutions. All they see is a great looking web page or a user experience that says, hey, this looks cool as hell. And you're thinking, do you have no idea what's going on behind the scenes? Of course they don't. And as a user, they shouldn't. That's the burden that we carry. But ultimately, I would say to that developer, start looking at the bits of the front-end development that excites you, and maybe start swimming upstream a little bit to see if there's other areas. So, for example, go to the API side of the fence. Is that an area you may want to explore? Or go maybe somewhere else. Maybe it's like a mobile development. Like mobile development didn't really exist 15 years ago. It wasn't until the iPhone came along and sort of created this rich environment that we suddenly had a new world to go for. We're starting to see a lot more of those sort of devices pop up in certain places. As a UX person, we still have a long way to go before our ceiling's reached, but I can see where the feeling has got where I've maybe reached a ceiling that's maybe not there.
Right. Very nice. So excellent, session, Alan. Really, because this topic, variations on this theme could be found on the internet in several places, but the content is so fresh and exciting and very, very insightful. We really appreciate you taking the time to do this for us. And for everyone who joined this webinar, I heartily recommend picking up Alan's new book, Think Like a CTO, which is going to be out in November, Alan.
Yes, and it's in preview now, and please connect with me on LinkedIn. Always happy to make new friends.
Okay, cool. So do connect with Alan, and then also pick up that book when it gets out. Thanks, Alan, for your time.
Thank you very much. Very humbled.
Yeah, thank you. Bye-bye.